Hi, my name is Søren. Welcome to this first video in a series about Morini ignition. Morinis are very reliable. You rarely have mechanical problems, and if you do, it's usually because of general wear, poor maintenance, or as I think is a number one source for faults, a mechanic that has been doing a second-rate job. The ignition isn't that different, though the parts are a bit more fragile. But we're talking about components that are 30 or 40 years old, have been exposed to salt, heat, vibrations, water, all kinds of harsh conditions that aren't really meant for electrical equipment. And also, they are often ignored because a lot of people are almost fearful when it comes to dealing with the electrical side of a bike. I will go through the various parts, not in extreme details, but I'll give you some solutions to the problems that might occur. In this video I will talk about the primary coil, but since this is the first video, let's have a look at our trusty manual. At page 110 you'll find this diagram. We have the generator, the battery, the rectifier, the ignition switch, the rev counter, the spark plugs, the pickup and the ignition boxes. And you can actually consider the ignition boxes as two units, as they consist of the electronic regulation and the ignition coil. If you're not a complete newcomer to Morini, you know that there are actually two power sources coming from the generator. The one that goes to the general supply and the one that goes to the ignition. For these purposes we will disregard the first one. When the magnets on the flywheel pass the primary coil, it produces a low voltage that goes to the ignition coils. These transform it to a high voltage that finally will be turned to a spark by the spark plugs. But the spark isn't fired until it's told to. And responsible for this are the pickup and the electronic circuit in the ignition boxes. The pickup sends a timed signal to the electronic circuit that then will trigger the coils to release the spark at the correct moment. The advance in relation to revs is mostly regulated by the electronic circuit in the ignition boxes, but also partly by the pickup, but more on that later. As a side note, I will also mention the rev counter. The early Morinis have an electronic rev counter and it receives its signal from either of the two ignition boxes. This applies only for the early boxes, as the later ones don't have this output signal. The primary coil is made just like the power supply coils. The most notable difference is the thickness of the wire. And the number of windings for the primary coil are in the thousands, and for the supply coils it's less than 100. The worst enemies for the primary coil are heat and vibrations. It may cause the ground wire to break loose from the coil, and the same thing with the output wire, the green wire. And you may also have a housing that simply comes loose from the anchor. But what most Morini riders will experience in time, if they ride long enough and far enough, is a degrading coil. The lacquer on the copper wire will with heat and vibration simply degrade. And when that happens, two windings next to each other will have contact, and they will then in fact act as if there's only one winding. And this of course will happen to more and more windings, and in the end you will have too few windings to get a decent output from the coil. The symptoms of a degrading coil are a weak spark on both cylinders. And you will have a hard time kickstarting the bike, especially when it's cold. You may be able to push start it cold and actually have no problems when the engine is warm. But that will also in time get worse and worse. And you can actually follow how things get worse and worse over time. There are a couple of things you can do to get an idea about the condition of the coil. And as it's stated in the manual, you can measure the resistance of the coil. If you do it on the bike, you disconnect the green wire that comes from the coil at the fuse box and measure the green from the green wire to ground. It's also stated in the manual that you should be reading approximately 300 ohms. I don't know where they got this value from, because I've never seen a new coil or a new old stock coil that measured more than 240 ohms. 200 to 230, 40 ohms, that's a perfectly good value. Usually we say 180, that's a minimum. But I've had a coil that measured 165 ohms and the bike was running perfectly fine. So it's not an exact science. Furthermore, you may experience a coil that measures fine, let's say above 200, that still is defective. So as I said, it isn't an exact science. If we look at this one at my desktop, you can see it measures barely 190 ohms and it's probably in working order. But there's another way you can measure the coil. You can measure the voltage output from the coil. So if you can get the bike started, you can measure the same place, of course with the green wire connected this time. You should measure around 90 volts at idle speeds and around 4000 watts you should measure 120 to 140 volts. These are of course the ideal values. You may get the bike running with way lower values, but you might have issues with starting the bike if the value is too low. If your coil is defective, I would simply recommend you buy a new one. You can rewind them, but because of the very thin wire and the many windings, it's a job that requires a lot of feel for it. The other ones, no problem. I've done it myself. It's an easy task. But this one, no, I wouldn't do it. You can get them from Wolfgang Tritsch in Germany and Northwester Motorcycles in England, and they're not that expensive. When you have to remove the old ones, there are two types of stators. The early ones, you will only see one copper plate on top of the housing. This is a later type, so it has two copper plates here, and the inner part is riveted to the base plate. You of course have to bore these rivets out, and then you can remove the copper plates. But of course not until you have bent the outermost plates of the anchor, which hold the housing seated to the anchor. But be careful not to break these plates, because you want to use them again, of course.
You may find that you will have a conflict with the other housing. It's not strictly necessary to remove the other coils. You can break off the excess from the housing if you don't need the housing again, and then drive it off. As far as I remember, I didn't have problems fitting the new coils with the ones I've replaced, but it is a tight fit. And if you run out of space, you can simply trim off a bit from the housing with a knife or something like that.
The copper plates of course serve a purpose. They act as a high voltage limiter. The coil will produce some very high peak voltages that are damaging to the ignition boxes and the coil itself. So the copper plates of course need to go back on. But there is a alteration you can make to the system where you don't need the copper plates. Markus Hallig from Germany has done a lot of research into the subject, and his suggestion is to put two, preferably three suppressor diodes in parallel to the green wire. You need 2 or 3 because they get hot and you can distribute the heat to several diodes. I would really recommend you choose this solution because the copper plates themselves produce some heat, which of course is contributing to the general degradation of the coil. And even if you have an old system with only one copper plate and you don't need to replace the coil and you still have the copper plates on, it's advisable to have a suppressor diode parallel to the green wire. It will take the high peak voltages that the copper plates do not manage to suppress. For both solutions, it applies that you should mount the diodes in some sort of heatsink. And here you see my solution to the latter. Problems with the primary coil are very common. The symptoms are no spark at all at both cylinders, if you have a broken wire, things like that. And with the degrading coil, you will have a hard time kickstarting the bike, especially when it's cold. Weak spark on both cylinders and the problem will get worse over time. So look out for mechanical issues, broken wires and things like that, and the coil will degrade. But you can prolong the life of the coil and the ignition boxes with a suppressor diode. So I would certainly recommend you do that. Fault finding, measure the resistance of the coil, it should be above 180 ohms, or you can measure the voltage output. It should ideally be 90 volts at idle speeds and around 120 at around 4000 revs. If you need a new coil, buy a new coil. They're not that expensive and they're simply too difficult to rewind yourself. Hope you enjoyed this video. Stay tuned for future videos about Morini ignition and thanks for watching.